Okay, guys, this is page 3 of chapter 3 exam review. In my packet, that's hanging around page 35 right now, I believe. So, when we last left off, just to flip back, we had, to the previous page, we had dealt with slope-intercept, we had dealt with point-slope, we had reviewed standard form. We'd hit all 3 of these forms, guys, pretty impressively. And then how to go between them. We talked about starting with point-slope form, distributing and getting y alone to get slope-intercept, and then from there, moving the x over to the left to get standard form. And we'd also discussed how to write vertical and horizontal lines here with these equations. Okay? So today, we're going to build on that. We're going to mix in some graphing. We're going to mix in some word problems. And then we're going to mix in parallel, perpendicular lines, as well as x and y intercepts. So just like yesterday, we've got 4 main things we want to talk about, and some of these are connected to each other. So let's do a little recap here and bring in graphing and slope-intercept, which we said was y equals mx plus b. So based on the graph shown, write an equation in slope-intercept form that portrays these graphs. So you're going to see we got some dots here, and I'm actually going to go ahead and connect those like they should be. So first thing we need for slope-intercept form, we need a slope. We need m, and we need b. So m looks like we're going up 1, 2. Remember, rise over run. So slope would be up 2, and then right 1. Ha-ha! And then where's our y-intercept? Well, that's where the point is crossing, where our line is crossing the y-axis. Here's the y-axis. Boom, right there at 1, 2. So b is 2. Our slope is 2 over 1, which is actually really just 2. So we've got y equals 2x, 2 over 1 is really 2, plus 2. And I'm going to let you guys try number 14 for me, please. Okay, so it looks like our line is hitting at the y-intercept at -3, and we're going for our slope down 1, right 3. So that'd be -1 over 3. So our equation is going to be y equals mx plus b, so -1/3 x. And then, instead of plus b, we got a -3, so -3. Nice work, guys. So that is how we write an equation for a line in slope-intercept form. Now, what if we want to deal with some slope-intercept in a different way? What if we want to see how we can create equations to represent situations in real life? You may not have thought about this, but slope-intercept form, y equals mx plus b, is great for representing real-world situations where one quantity changes at a constant rate in relation to another quantity. So I want you guys to be thinking, let's be thinking about y equals mx plus b, and I'm going to give you guys a chance. Go ahead and read over number 15 for me, please. Let's just read it. Let's see what you guys pick up from this. Okay, guys. So first off, we know y is going to be the total cost of the pizza. Okay? So first thing I'm going to say is I know that everything's got to end up equaling y. Y is going to equal everything else. But I also want to recognize that along with this being the total cost, x represents the number of extra toppings. And then what's connected to that? Well, each extra topping is going to be 75 cents. Okay. And how much does a pizza cost in general? Well, a single topping pizza, that costs $8 just straight up. So we know MX, if X is the number of extra toppings, what's the slope going to be? How much is our price changing for each extra topping? Oh, 75 cents is our slope. So M, 75 cents is our slope, because every new topping, it costs 75 extra cents. Plus, how much does a pizza cost without any toppings? For a y-intercept for B, we know that's whenever X is 0. If X were 0, how much does a single topping pizza still cost? Still costs $8. So Y equals 0.75 cents times the number of extra toppings plus $8 for just this basic pizza. I swear, guys, that's a tough one. I mean, one of the toughest problems we do, along with number 17, which is going to be tough. This is going to be a tough one. I want to give you guys a chance to read. Go ahead and read number 17 for me, please. So first thing I see is we have a point that we know is on the graph of our line. So this point is on our line. Well, wait a minute. So that we got an X1 and a Y1. And we're told another point on the graph can be found by going, wait a minute, going up 21 units and 29 units to the right. So we can go from one point to another point by going up 21 and 29 to the right. Now, wait a minute. I don't know about you. Doesn't that sound like rise over run to you? We rise 21 units up, and we go right, which is positive, 29 units. So what did they just give us here? They just gave us the slope. So we have a slope, and we have a point. Are you guys thinking what I'm thinking? I'm thinking we're about to use point slope form. Now here's the kicker. This is the tricky part. We're going to need to eventually write this equation in slope-intercept form. Eventually we're going to need to make it to y equals mx plus b, but till that point, why don't we start in point slope form? And if you can't remember, y minus y1 equals m times x minus x1. So we've got y minus y1. Ooh, y1's negative 12. So that really becomes a plus 12 equals our slope, 21 over 29 times x minus, x1's negative 7. We know that's going to turn into a plus 7. Minus a negative turns that into a plus. Okay. So we have point slope form. Now, we got to make it to slope intercept form. How are we going to do that? Well, step 1. We need to distribute. We need to simplify this bad boy down. So let's go ahead and distribute 21 over 29. That gives you 21 over 29x plus, I have no idea what 21 over 29 times 7 is. Let's try that out. Oh my goodness, that gives us something terrible. I'm going to turn that into a fraction. That is 147 over 29. Goodness, I think I probably could have chosen a better number here. And then finally, step 2, you want to get y alone. If we're trying to put this into a slope-intercept form, that's y equals mx plus b. Y needs to be by itself. So right now we got plus 12 here. Let's subtract 12 from both sides. And I have no clue what that's going to give us. I'm going to pull this over here. Y equals 21 over 29x, and then 147 over 29 minus 12. Okay, negative 201 over 29. And again, guys, don't expect to have to worry about getting a terrible fraction like that. This is not very normal. But, so yeah, those two steps are normal, though. To go from point slope to slope intercept, we distribute and then get y alone. So y equals mx plus b. Whew. Sorry, that was a tough one, guys. Probably the toughest one we're going to do today. Now, on to almost the last page here. We've talked about graphing. We've talked about going between the forms. We've talked about word problems. Now, let's talk about being able to graph by finding x and y intercepts. Now, I don't know if you recognize this. What form helps us with this? What form helps with finding x and y intercepts? That's right, standard form. And we saw standard form yesterday. That is ax plus by equals c. And I want you to notice something. Ax plus by equals c. Ax plus by equals c. This is already in standard form, which is perfect. That means in order to find x and y intercepts, all we need to do, terrible circling, is do the algebra. So to find the x-intercept, that's going to be a point that is on the x-axis. And if it is a point on the x-axis, what do we know y is going to equal? Going to equal 0 because, again, a quick reminder, x and y axis, and let's say you had a line go through there. We know, boom, right there is an x-intercept. That would be maybe negative 3, 0. Notice how y is 0? It will always be 0 if it's on the x-axis. That's an x-intercept. Just like up here, we could say that is a y-intercept, and that might be maybe 0, 2. And guess what? X will always be 0 with a y-intercept. So, to find the x-intercept, make y 0. To find the y-intercept, make x 0. So it'd look a little bit like this. Negative 4x minus 2 times, instead of y, 0, equals negative 8. And then over here, negative 4 times, not x, but 0, minus 2y equals negative 8. We work both these out. That cancels. You're left with negative 4x equals negative 8. Divide by negative 4. Remember, we don't add. It's being multiplied. And you get x equals 2. But guys, just be careful. Because remember, x and y intercepts, these are points. So it's true x is 2, but what would the coordinate be? Well, it would be 2, and then y is 0. Same thing over here. Negative 4 times 0 cancels. You're left with negative 2y equals negative 8. Divide by negative 2, y equals 4. Nice voice crack. Remember, we got our coordinates. X is 0, y is 4. And all you need is 2 points to graph a line. I'll write that over here. We just need 2 points to graph. That's all we need. So I go 2, 0, start at the origin. 0, 0, we go 1, 2. Don't have to go up or down. And then over here, 0, 0, we go up 1, 2, 3, boom, 4. Now, if you wanted to, you could say, wait a minute, that is down 1, 2, 3, 4 over 1, 2. And then you could go down 1, 2, 3, 4 over 1, 2. You could 100% give yourself a little bit of a straighter line there if you wanted to, but you don't have to. I'm going to let you guys try number 19, please, and we will check it here shortly. Let's see how you guys did here on number 19. So we work it out. We get x equals -3. So our x-intercept is -3, 0. We work out our y-intercept, and you end up getting 0, -2 for your y-intercept. So I go to graph them. -3, 0 goes there. 0, -2 goes there. And once again, we get a negative slope. Downhill line. All right. And so, guys, let's finish off with the last thing we're going to be talking about today, parallel and perpendicular lines. Actually, I did orange with the last one, so I'll go pink for this one. So we want to be able to understand the difference between parallel and perpendicular lines. So quick reminder, we know parallel lines. I'm going to write this down. Parallel lines have the same slope. You got the same slope. Perpendicular lines have what's called opposite reciprocal slopes. So either way, it's about the slopes. But with perpendicular, that means you change sign and flip the fraction. And of course, that's if you have perpendicular. If you have parallel, then they're literally just the same slopes. So let's look at what we got here. What would be, okay, so we're actually looking for what would be an equation that is, parallel to y equals 5x plus 1. So here's the thing. If it's going to be parallel, we know they have the same slope. Well, what's the slope of this line? Slope of 5. Well, guess what? Our line has a slope of 5 too. Here's the thing, though. What's the b? B is 1. Our line can have any b, but, it's a big but, any number but 1. And here's why. If our line is the exact same as this line, they're not parallel, they're the same line. We can't have that. We need our line to be different. So our b can be any number but 1. So maybe y equals 5x plus 7. So different y, same slope. Right? Here's where things get a little bit tricky. What happens if we want to do what would be an equation of a line that is parallel? So once again, parallel. This time, though, this is in standard form. That's a problem. We need the slope. And right now, this form does not tell us the slope. What would happen, though, if we put this thing into, let's change to slope-intercept. Let's change this thing to slope-intercept form. So in order to do that, that means we need to get y by itself. So let's start by putting this thing into slope-intercept form. So we need to get x. We need to get 4x back onto the right side. So add 4x over. You got 9y equals 4x, and it doesn't go with 14, so they just go right next to each other. So plus 4x plus 14, and then we got to get y alone. Remember, slope-intercept form, y equals mx plus b. So divide by the 9. So this equation right here is really y equals 4 over 9x plus 14 over 9. So our line, we did all that work just so that we can finish this problem real quick. Our line needs to have this same slope, 4 over 9. So y equals 4 over 9x, but we need a different y. So I'm going to go -3. This could be any number but that right there. Any number but that right there. I went with -3. So here's what I'm going to let you guys do. I'm going to let you guys try numbers 22 and 23 for me. And be careful, because this time we're talking perpendicular. So this time you're going to need to find a slope that it has a different sign and is a flipped fraction. So go ahead and try 22 and 23 for me, please. Okay, so if our line needs to be perpendicular to this line, we need to figure out what this line's slope is. Looks like it's negative 2 over 3. So to get our line slope, I'm going to flip that fraction and change the sign. So now we have positive 3 over 2. And fun fact, your y-intercept can be any number in a perpendicular line. Because as long as the slopes are opposite reciprocal, they're going to intersect and form 490-degree right angles. So I'm going to go y equals 3 over 2x plus 12. Use one of my favorite numbers. Down here, we know this slope is 5. Well, that's really 5 over 1. So if we're trying to create a line that is perpendicular to that line, our slope is going to be the opposite sign. So if that's positive, our slope is going to be negative 1 over 5. And our y-intercept, once again, could be any number. You can choose any one you want. So I'm going to go y equals negative 1 over 5x. I'll go minus 4. But it could literally be any number. We could have put plus 1 here. That would have been okay. But yeah. And so that is how we create lines that are parallel or perpendicular to lines that have already been given. It's all about the slope. All about knowing the slope. Even if it's in a form where we don't know the slope, we just change it to a form where we do know the slope. Okay, so we're going to finish, guys. And I just want to give you a chance to try. We're going to write what slopes would be for the lines given here. Just try numbers 25 and let's go number 25 and number 27. Give those a quick try. See what you guys got here. I would draw an X. There's a y-axis and an x-axis. And same thing down here. And go ahead and draw with another color what we think these lines would be and what their slopes would be. So go ahead, guys. We see that a line parallel to the x-axis would be a horizontal line, and we know the slope of a horizontal line would be 0. A line parallel to the y-axis would be a vertical line, and we know the slope of a vertical line is undefined. So remember, guys, we got our quiz tomorrow. Hope you guys study up. You'll have all day to take it. Good luck. And ask me any questions if you have them. You guys know how to reach me.